Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 3 from the C34 International A-Level Edexcel paper from the old syllabus of pure mathematics. Now this question would be classified under P2 actually. It has to do with the trapezium rule and then some questions related to your answer found in the trapezium rule. So this would now be a P2 question. So I'm going to save this under my P2 material. So here we got this sketch of a curve. This is P2, by the way, for Edexcel that I'm talking about. So it says, it shows a sketch of the curve with the equation y equals 10 over 1 plus root x, where x is greater than or equal to 0. It says the finite region R, shown shaded in figure 1, is bounded by the curve, the line with equation x equals 4 and with the equation x equals 3. X equals 6. Use the trapezium rule with 4 strips. Okay, that's important here. With 4 strips to find an estimate for the area of R. Show your working and give your answers to 2 decimal places. Okay, so what we have to do here is we have to find the area of this region, not by integration, but by using the trapezium rule. So we're going to be basically estimating the area. It won't be an exact answer. It won't be the exact answer. It will be an estimate of the answer, which is what is required because we're using the trapezium rule. So we're going to split up this area into 4 equally, four, you can say strips of equal width. So I'm going to make a line kind of like halfway. And then I'll need another 2 lines halfway between the others. So something like this and something like this. You don't have to draw this at all. I'm just trying to illustrate what's going on when we use the formula. There's actually a formula for this in the formula sheet, but I want you to understand where that formula comes from. So we're basically splitting up this area here into 4 equally spaced kind of 4 equal widths. 4 strips of equal width, you could say. So you have these 5, in the end you have 5 lines. 5, they're called ordinates. These are like the ordinates, okay, of these strips. So you have 1, 2, 3, 4 strips of equal width, and we can see very clearly that the width of each of these strips is basically half. That's 4 to 4.5, 4.5 to 5, 5.5 to 5.5, and then 5.5 to 6. So each of these have an equal width of 0.5. Okay, so there's a 5 here. So each of them has a width of 0.5, and that's what we call the value of h, which we're going to see in our formula. Okay, so basically the value of h is found by taking the beginning and the end values where you want to find the area and dividing by the number of strips that you want. The number of strips was 4, so that gives you, as you can see, a half. So the value of h is a half. And we can also see that when we're using the trapezium rule, what we're doing actually is we are basically approximating the tops of all of these strips as having straight lines. Okay, so we're kind of ignoring the fact that they're curves and kind of making them into straight lines and treating them like trapeziums. Right, so we have basically here 4 trapeziums, and the trapeziums have their vertical height, or the distance between the parallel sides, you could say, as half, and these are the parallel sides. So the first trapezium has one parallel side, let's call it y1, the second one y2, the third one y3, and then you got y4 and y5. Okay, so the first trapezium has these 2 as its parallel sides, the second these 2, the third these 2, and the fourth those 2. So you have trapezium 1, 2, 3, and 4. So if we are thinking about finding the area of this trapezium, of this whole shape, we could find the area of each of these individual trapeziums. Okay, so you'd have, for the first trapezium, you'd have the distance between the parallel sides, which is h divided by 2 times, because we know that the area of a trapezium is given by basically a half times the sum of the parallel sides, okay, times the height. Okay, that's the area of a trapezium. So you can say h over 2 times a plus b, the distance between the parallel sides times the sum of the parallel sides. So here, the sum of the parallel sides here for the first trapezium would be y1 plus y2. Okay, and then you'd have the second trapezium, which is going to be, again, h over 2 times, but this time you'll have y2 plus y3. And for the third trapezium, you'll have h over 2 times, and you'll have y3 plus y4. Okay, so that's 1, 2, 3. And the last trapezium, you'll have h over 2 times, and this will be y4 plus y5. Okay, so that will give you all of the areas. And if you see here, when you try to add them together, you have a common factor of h over 2. And then you have basically y1 plus y2 plus y2 plus y3 plus y3 plus y4 plus y4 plus y5. So you'll notice that the first and the last are only mentioned once. So I'm going to put y1 plus y5 plus, and the ones in the middle are mentioned twice. You have y2 plus y2 plus y3 plus y3 plus y4 plus y4. So you have 2 times y2 plus y3 plus y4. And that will give us the area, the estimate of the area of the trapezium. Is an estimate because, there's some parts here which are slightly not going to be, taken into account, or maybe it might be overcompensated for. In fact, here they'll be overcompensated for. So if you zoom in, something that's kind of slanted this way, our trapezium will include this area which isn't there. There will be a slight difference. So we would get like an overestimate with this. Anyway, so this formula will help us now. And this is the formula. It's written kind of like in this form in the formula sheet. And this is what it basically is doing. So you have to find the distance between the parallel sides, which is basically how wide each of the strips are, which in this case is 0.5, divide by 2 times the sum of the parallel sides, which is going to be basically the y value when x equals 4. The y value when x equals 4 will be this height here. That will be the y value when x equals 4. That's y1. And here will be the y value when x equals 4.5. And the y value when x equals 5, and so on. So what I'm going to do is, instead of making a table of values, which you could do, I'm going to just basically just put it in like this. So when y equals 4, I'm going to have 10 divided by 1 plus root 4 plus, and I'm going to put for y5, the last one, plus 10 over 1 plus root 6. Okay, so that's the first and the last. And then I'll put 2 times the ones in the middle. So I have 10 over 1 plus 4.5, root 4.5, sorry, plus, and I have 10 over 1 plus root of 5, plus 10 over 1 plus root of 5.5. And that should give me an estimate of the area. So we can say the area is approximately equal to this, and this is equal to, so I can just stick all of this in my calculator. Okay, so let me just get this inside. Oops. All right, and now I'm going to stick this in my calculator. Okay, so I have 10 plus, so I'll have 0.5 divided by 2. Oops. 0.5 divided by 2 times. Then I'll have the first and the last, so I'll have 10 over 1 plus root 4. And then I'll have plus 10 over 1 plus the last one, which is root 6. And the rest of them are going to be plus twice. I have 10 over 1 plus root 4.5, sorry. 1 plus the square root of 4.5. And then plus, and I'll have 10 over 1 plus the square root of 5. And, whoops, I've gone too far. Then plus, and then I'll have 10 over 1 plus the square root of 5.5. 5.5. I'm going to close the first bracket for the 2 times, and the last, the other bracket for the outside bracket. And that should give me my estimate, 6.1997. So we get 6.1997. second to get this sorted out. So we have 6.1997 continues on. Now the question tells us to round to 2 decimal places. So that's going to be 6.20 square units. So there's the answer to part A of our question. Now for part B of the question, which is a very common type of question that comes in P2 nowadays, is using your answer to part A. Using your answer to part A, it says, and making your method clear, it says, estimate the value of the integral between the limits of 3 and 2 of, now the expression looks different, 60 over 1 plus root 2x with respect to x. And this is what we found. So what we actually found in the previous part of the question was the integral between 4 and 6 of 10 over 1 plus root x with respect to x. We found an approximate value for that as 6.1997, which rounded to 6.20. I'll leave that. This is a more exact value. That's fine. If you wrote 6.20, that would be perfectly acceptable as well. Now we have to try to figure out how we can use this answer here to find this integral, to get an approximate value of this integral. And you see that they're kind of related in a way. What I can do first is I can see that this is like 6 times that. So you can put 6 outside. Okay, so you have 6 times 3, 2, and you have then 10 over 1 plus root 2 dx. Okay, so if we call f of x, for example, if we call f of x our original function, which is 10 over 1 plus root x, what we have now, we can say that 60 over 1 plus 2 times, 1 plus root of 2x. What's happened here? It's like you've taken the original function and you have multiplied by 60, and then you got 6, sorry. It's like you multiplied it by 6. So now you have 10 over 1 plus, and it's like you replace the x with 2x. Okay, so you've replaced the x with 2x and you multiplied by 6. So you can say that this is the same as 6 times f of 2x. Okay, 6 times f of 2x. So if f of x is 10 over 1 plus root x, this is like 6 times the whole function, and then you replace the x with 2x. And 6 times f of 2x, two things have happened here. We have a horizontal stretch of factor a half, reciprocal of this, and we have a vertical stretch of factor 6. So this is stuff from P1 actually, which is needed to be understood in this question. Okay, so we have two things going on. We have a horizontal stretch of factor a half and a vertical stretch of factor 6. So how does that affect the area? So the horizontal stretch of factor a half will basically make this become a half of the area. So basically what's going to happen is this area is going to be, we want to find, and we can see that we're finding the area between 3 and 2. Okay, between 3 and 2 is going to be over here. And it's like we've taken this and we've taken this, the same area, and it's now between 2 here and 3 here. So these values have been halved. So it's like this area, okay, is going to be half of that area. Okay, and what's happened also is been stretched by a factor of 6. So you can say that the area is going to be multiplied by 6 and also multiplied by a half. So that you're going to have this times the area of the original function. Okay, so it's going to be 3 times. The area is going to be 3 times because it's going to be stretched by a factor of 6, and it's going to be vertically by a factor of 6 and horizontally by a factor of a half. So the area is going to change by being 3 times of what it was before. Okay, that's what's going to happen now. So it's going to be 3 times the original area, which was 6.1997. So that should give us times 3. 3 times that gives 18.5996, so 18.6. 18.60. 18.5991. If we follow the same protocol as before, 2 decimal places, 18.60 will be our area. Okay, so that's kind of how we can imagine what's happened. That area, this it's been stretched by a factor of a half, and it's been stretched by a factor of 6 vertically. So the total combination of those will be the area has been multiplied by 6 and also by a half, so it's been multiplied by 3. Okay, so that's, you know, using transformations, okay, to work out what's happened here. So yeah, so that's because of course this is not the same graph. This won't be the same graph of this. It's going to be, it's going to be higher up as well. So it's not the same graph. The area is going to be this area, according to this transformation, it's going to be half the area, okay, because the base has been halved, and it's going to be 6 times the area because the height has been raised by 6. So it's going to be 3 times the area in total. Okay, so I hope that's clear. It's a bit of a complicated one, but that's that question here. Now, for part 2, we have to use the same. Yeah, we got it here. We use the same area, so we know that the area is approximately, or we can say the integral of between 6 and 4 of 10 over 1 plus root x with respect to x is equal to, and then what was it again? It was 6.1997. Okay, so that's approximate area of this, of R. And so that's therefore the approximate value of this integral. Now, we have to try to find the approximate area of this integral or the approximate value of this integral using that. So we see that what's the same here is the denominator. So what I'm going to do is I'm going to try to write this. I'm going to take this, the original, or the thing that we're asked to find the value of, and I'm going to try to rewrite it in a way that it looks in terms of that. So what I'm going to do is I'm going to write here 10 over, I'll get rid of this. Okay, 10 over 1 plus root x, and I'm going to add to this 3 plus 3 root x over 1 plus root x. Okay, because this will be 13 plus 3 root x is the same. These two lines are the same. This is going to be with respect to x. Now I know the value of this, so I'm going to write this separately. So the the integral of between 6 and 4, 10 over 1 plus root x with respect to x. I know the value of this. I know that's the approximate value of this. And I'm going to have here the integral between 6 and 4 of, and I'm going to take out 3 as common. I have 3 times 1 plus root x over 1 plus root x. And what you notice here is these are going to cancel out. Okay, so we're left with something which we know the value of this integral from the part A, which is what we had to use. 1 plus root x with respect to x, plus, and I have got to find the integral between 6 and 4 of, and we're left with just with 3 with respect to x, which I do know how to integrate. So this is going to give us our answer from part A, which is basically 6.1997. plus, and if you integrate 3 with respect to x, we'll end up with 3x. We've got limits between 6 and 4. So that's going to give me 6.1997 plus, and you're going to have, when you put 6 in here, you'll have 18 minus, and you're going to put 12 in here. So it's going to be this plus 6, which is 12.1997, which gives you 12.2, if you stop there, it'll be 12.20 square units. So there's the answer to part 2 of this question. So that part B finished, and that concludes this question. So this one, you gotta just try to, I mean, these questions are quite tricky, but you have to try to express things in the form of what we have the answer of. We know the value of that from part A. So I try to look at this and try to extract that from here. So, okay, how can I write this so that I get 10 over 1 plus root x? And then, of course, they have to be the same as this. And then you notice, okay, these will cancel out. So it works out. And the first question is a bit more tricky, actually, because of this root x in here. I mean, for us to do that in another way would be a bit more tricky. Let me see if I can think of a way. Question 3B part 1 again, just to try to make a bit more sense out of it. Okay, before I mentioned it's like, 6 times, make this pen a bit smaller. It's like 6 times f of 2x. If you compare this to that, if this is f of x, if f of x is 10 over 1 plus root x, then what we have here is 6 times f of 2x. It's like you've multiplied by 6, you get 60 over 1 plus, and you replace the x with 2x. So you can say it's a horizontal stretch of a half and a vertical stretch of 2. So you're multiplying by 6 times a half, so you're multiplying the area by 3. Okay, so if you change the base, if you half the base and you make the width, the height 6 times as big, then you will change the area by a factor of 3, so it's 3 times the area, which is quite an easy way of thinking about it. But if you're thinking about this in terms of more like trying to make this look like that, so we can say, okay, this is like having 3, 2, and you have 6 times 10 over 1 plus root 2 with respect to x. Now, for us to make, see, this is between 2 and 3. This is between 2 and 3. So it's like 6 times the area of this graph between 3 and 2. Okay, so let's say that's 3. Let's say that's 2. Okay, so basically, oops, that's 3 and that's 2. So this is what that would look like. This area, okay, of this would be basically what this is. Now, so that's what the area of this would be. And compare the area of this to what the area that we have. We have this area. So how do they compare? Okay, so as we mentioned, it's like if you were to make this into that graph, you would have to multiply the x coordinates by 2. Okay, if you were to make this become that, you have to make the multiply the x coordinates by 2, you'll have 4 and 6. Okay, and so therefore the area of this is going to be a half of the area of that. Okay, because it's going to be the base of this is going to be divided by 2. So the area is going to be a half of that. Yeah, so basically, if you were to change this to become that, it's going to look exactly like this. This will become, if you make this between 4 and 6, and that 10 over 1 plus root x, it will look exactly like this. Okay, it will be the same area. Okay, so this is like half of that area. Okay, so therefore you multiply the area by a half. So the area is multiplied by a half, and then it's multiplied by 6 because of the vertical stretch, 6 times the area. So that's how we could think of this. Okay, so you can think of this as 6 times a half of between 4 and 6, the area of 10 over 1 plus root x. So this is the same as that. Okay, so if you take a half out of here, then the limits were going to be doubled, and that's going to be root x. And that's what's going to give us the same area half, 6 times a half times, and that's what we already have in the previous question, 6.1997, and that gives us our answer. So that's another way of thinking about part B, kind of. So I hope that makes it a bit clearer. But yeah, that part B, part 1 is a bit more kind of, what's the word, you know, a bit more thought involved in it. I don't know if you look at the examiner's report how many students actually got it right, but it's a bit more involved. But this is a nice way of thinking about it as well, as I mentioned earlier. Okay, just to try to make a bit more sense of it. So there's the answer to this question number 3. I hope that was clear. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of the video. Other questions from the topic of the trapezium rule, and I'll add it to my P2 collection. You'll find it in the playlist in the bottom right of the screen at the end of the video. You can subscribe to my channel by clicking on this link, and here, the video at the top of the screen will show you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.